But if you have any questions, please don't hesitate to reach out to me. My goal here right now is just to talk about a couple of the slides to any of the new visitors we have or new members we have, or people who just like pizza. But I want to talk about some of the ways you can get in touch with us. The first one is we do have Twitter. We try to get on all forms of anti-social media. So we have a Twitter handle that sometimes points to some of the other things. We run our own Slack, and it's a self-invite. So if you follow this link, you can self-invite yourself. We're pretty open that way. We also have the meetup page, which I presume you've seen since you've actually made it this far. The other thing I want to bring up is, if I can find the slide. Sorry, I'm not used to this particular laptop. There, awkward pause. I just wanted to shout out to some of the volunteers we have. I co-lead with Sharif and Paul, who can't make it this evening, but they're usually here. But also Adam and Scott, who help us with videos. Nancy, who's also our co-lead, and Dave, who's probably been handing out cards for us and working the door. And Rick, who sets up the PSAs and is Minister Without Portfolio. And he's also the guy that if I say zap, so I know, there's a lot of reasons we keep him around. So before we get started, there's somebody who would like to offer you a job. So I will invite Harish to do the pitch. No, it's not Wolf of Wall Street. He's not going to throw money at you.
All right, so I'm Harish. I actually moved to Ottawa last week. So working for Mitel, I'm a security architect, and we desperately need more security architects there. So just reach out to me. So it is, the role is pretty awesome. So it's a cloud application architecture and some of the stack. We've got custom protocol, voice, real-time protocol, Linux, Windows, C, TypeScript, C#, iOS, Android, Java, real-time, and IoT, just to throw in some of the buzzwords. So really awesome. So I think rather than being in a corporation, looking at those reports and the vulnerability scans and things like that, this is you're welcome to join and make a real difference. So moving to the application security, cloud, and things like that, and we really need people. So I'm going to be here till the end. Just reach out to me. Thanks, guys.
I was beginning to wonder if it would have been easier to just list the technology you don't use. Oh, okay. Jeez. Okay, who recognized those words and will admit to it? All right, so our first presentation is going to be from Andriy, who's going to talk about some of his hacking experience against the Brainpan box. We need to give him a big round of applause because he's just got his OSCP. So, a show of hands, who here has tried OSCP? Working on it. We're all working on it, I know what you mean, sister. Oh, we got another hand over there. Trying. Done. Awesome. It is. I've seen people try it. And it's scary impressive. So I am in awe. So please teach us.
Thank you. Before I start, just wanted to say, I have slides, but besides slides, I want to show how I do it. So my name is Andriy, and let me show the first slide. Yeah, sorry. Yeah, so my name is Andriy, and I test refer for a living. I got my OSCP and CH, and what I like playing with hack-the-box machines, and for work I do some security assessments and write end-to-end tests, CI/CD pipelines, and Docker. That's what I do. And today I wanted to talk about Buffer Overflow and a machine called Brainpan. You can just download it from Vulnhub. And why this machine? Because it's a really good example. You know, if you plan to pass OSCP, you have this machine on the exam and it gives you 25 points. I just wanted to show that it's really not that hard to do it if you do it right. Just, you know, a couple of simple steps. So let me start. Yeah. So this machine has ports, 2 ports open, and from port 10,000 you can just download the exe file, and yeah, it's in the bin folder. And if you're interested, I have a write-up on my blog where you'll be able to kind of read how I did it. Yeah, so for this presentation, we'll be using Oli debugger. You have it installed in Kali Linux, so you don't. I think you have it by default. Yeah. Okay. Okay. So this is my Kali Linux, and I'll just open the Brainpan exe file. And we also have to start it. So the exe file is started, and we can just try to overflow it. Okay. So what we have to do first? First, we need to figure out the not the precise, but the about size of the overflow. So we'll try to send 100 symbols, and in our case, it'll be A. So this is a simple Python script, and all we do, we just send on port 9999 on our local host. We send 100 A's, and we just increase it by 100 until we overflow the application. So it's that simple. I will just show it. So it crashed somewhere around 600-700 bytes, and we can open it here and open our Oli debugger, and we can see here EAP is 41, 41, 41. It means it's our A symbol, which is 41. So we know it's somewhere 600-700, right? So now we need to figure out you know, the exact number of symbols we need here. So for this, we will use a tool that's called Metasploit. It's part of Metasploit. And yeah, let me just show it here. Yeah, I'm sorry, it's not working the way I want, but I'll do it. Yeah. So the tool is called Pattern Create, which is part of Metasploit framework. And what we try to do here, we'll just pass 600 symbols, which will create a pattern of unique symbols. And we'll try to send those, instead of sending just A's, we just send a bunch of A's, but now we try to send 600 unique symbols and try to figure out the exact number we want for our overflow here. So what we need to do is just restart the application, run it. And for this, we need to have a new file. So just let me show it to you. So here, I just modified the previous file, and I can, just could save it, but I have a new file for every step. So here I put those symbols that we just generated, the 600 symbols. And we do pretty much the same we did the previous step. We just send those symbols to the application that is on our local host to the port 999. Okay, so we have overflowed. Okay, now we have to pay attention here. It's AP, we need this number. We need this number to figure out the exact number of symbols that we would have for the overflow. Let me switch back to my slides once again. So here, once again, we'll use a tool. Now it's called pattern offset. And it's also part of Metasploit framework. And on the exam, you can use those as much as possible because there is some limitation on some tools from Metasploit that you can use only against one machine. This one you can use as much as you want. So this is a number we recorded in the previous step. And when we run this command, we'll see that the exact match offset is 524. So we save it for our records here. And next, we just need to create a new file. Okay. So we created a new Python file, and now we don't send 600 A's, or we don't send this, unique pattern. Now we know it's 524, right? So we'll send 524 A's, and we send 4 B's, and the rest will be C. And you'll see why while we have 4 B's just in a second. So what we need to do, we just need to restart. So we'll restart our application. Okay, it's listening. And we'll just run this Python file again. Okay, perfect. So let's pay attention to this one, EIP. So you can see it's 42, 42, 42. If you see that, we are sure we get it correctly. So it means we have the correct number of symbols, which is 524. And right next after it goes the AAP. And if it's 42, which is B, right? So this symbol B, we had 4 Bs we were sending right after the A. So it means we are on the good track. So we doing it correctly. Okay, let's look at the next file we have. Okay, so we figure out we have 524 symbols, and now we need to figure out if there are any bad characters that will not work for us. So, you can just Google it, bad characters, and put them here. And why we need to do that? This is very important because if there are some bad characters that will not work with your application, your code simply will not work. So we will need this for the step where we generate with MSF Venom our, reverse IP and port where we specify the payload. So what we do here, we just send all those bad characters, and then in the debugger, we'll check if every symbol we send here is displayed correctly. So usually, if it's not displayed correctly, it'll be showing B0 very often. I would say that. So okay, let's try it. Let's just restart the application and run this fuzzer3 Python script. So I will restart it again. Run it. So we can click ESP and following dump. And over here you can see we have 01, 02, 03. Those are our characters. Those are bad characters that we send. And you can just, scroll down all the way to FF here. And, there are automated way to do that. If you use the immunity debugger and Mona, I think you can kind of automatically check, but you can just manually go and see if every symbol is displayed. If it's not, it can be, as I said, it can be B0. Like, for example, you will have 99, 9A, you'll have B0, or whatever else, but something that is not expected. If it's the case, you have to record that. This is an easy machine. You don't have bad symbols here. So every bad symbol is displayed correctly in this situation. But for other machines, you may have this issue. So this is something to remember. If you see that the sequence is not correct, like you don't see, whatever, A9, AA, or AA, BB, you just have to record that. And in the next step, I'll show why you need that and where you specify it. So here, so we need to generate our shell code where we specify the IP address of our Kali attacking machine, the port will be listening at. And over here, when you have -B, you specify all the bad symbols you found. 00 will be always there, but if you find more, you'll specify those bad characters you found, those that were not correctly displayed in the previous step. And I can just explain more. So, if you do hack the box, or you know what is MSF Venom, will just generate this shell code, and here we'll specify the payload. So the Brainpan, it's a Linux 32 bits, so we'll specify Linux and x86 and reverse shell TCP. And we'll specify the local host and the port will be listening. and it will generate this code that we will use for our needs. Okay. So we are almost there. There is one more step we need to figure out. It's called JAMP ESP, and we need to find the address of this JAMP ESP. So in our debugger, we can just right-click here and search for all and just type JMP ESP, and it will find the address that we need. So also I want to point out, this is easy machine and you can just do it like this, but you may have exe file and you will have zeros here. It will have protection and it will not work like this. So besides having exe file, you may have DLL file with it. So what you do, you just load DLL file to the debugger the same way we load the exe file, run it, and do the search. And it will have some kind of address here. So you'll copy this address for your nodes. So just saying once again, it's very important because your code will not run, your overflow will not work. So what is JAMP ESP? It's like a link to address in memory, and it will make your shellcode start. Hope it's a correct explanation, but this is how I understand it. So you copy this and save it somewhere. We'll need it for our final Python files that will run against the application. Okay, so this is how our final Python file will look, and I'll try to explain. So this code we generated with MSF Venom. That's okay. So we have 524 arrays. Now we add this address of JAMP ESP that we just recorded. But here we have to put it in reverse order. So I put it here. So this is the address, and it has 31, 17, 12, F3. So we just put it in reverse order. It's F3, 12, 17, 31. And we put it here. We add nope. Nope, it's like a space between JAMP ESP address and the shell code that will be generated. And then, of course, we put the buffer here in the end. And you don't see it in the screen, but then you have all this normal, the rest of the file where you specify the port and the IP address. So right now, I'll just show it in my Kali, and we'll try to run it again against a virtual machine with Brainpan, and see if we can get the shells there. So here I have generated the code, with my IP address. And I will be running against the IP address of the virtual machine that is running locally here. So it's listening port 9999. Okay, let's just run and try, see if it works. Okay, it may not work. Okay, I think I have issues with my network. Sorry? Yeah, so the application is listening on port 999, but to get the exe file, they have a port 10,000 where you have a folder bin and you can just download the exe file. They just, make it this way. So it was working before I arrived here, but so we can do. Yeah. So I wanted to show pretty much a real situation, but I can just run it against myself. I will just run exe file and just try to get shell to myself. Just give me a second. So here I have another file. Okay, this one should work. So let's start listener. On port 8080. Okay, it's too much. Okay, let's try it. Oh, it's supposed to be Python. Okay, so we got reverse shell. You can see it here. So I got reverse shell to myself because I was. Oh, thanks. Yeah. Excuse me. Yeah. So as you can see, we got reverse shell to the local host. But this is the idea, and what I want to sum up. If you follow those steps, you're not supposed to have any problems. Really, you simply have to figure out the exact number of symbols you need to send, which is 524 for this case. You need to figure out the bad symbols and just manually check those. And when generating your reverse shell, it just specifies those. And boom, it should work. Any questions?
What was the server that you're trying to hack?
So it's a site called Vulnhub where you have a bunch of vulnerable machines where you can practice hacking, and this one is called Brainpan. You can just go download, and run it on your local machine and just practice. Yeah, of course. But you can download that one and you'll have exact same steps. If you're interested in the OSCP exam, of course, those will be different. You'll have different size of, you'll have a different number of symbols and you have to figure it out yourself. But if you follow those steps, you should be good. Thank you.
So I just have one quick question. So we're seeing the distilled version of all the work you did, but the initial work and trying, how long was that in a rough estimate?
So honestly, for me, it was very hard. I read several times official material from the OSCP. They have a video. I watched the video a couple of times. I couldn't get it, honestly. And the night before my first try, I just found a nice video from a guy, and I read one I think write-up or something. I was like, bingo, I understand it. So it took me near 5 hours the first time to do Buffer Overflow. but when I truly understood it, it's not that hard. But yeah. Thank you.
So we'll just get set up for the next presentation, and then I'll introduce Ben. All right, so Ben's going to talk to us about file upload vulnerabilities. Ben's been a software engineer for 20 years, and you're currently at SurveyMonkey. Awesome. So here you go.
All right, great. Thanks very much. Okay, so welcome. My name is Ben Whitney, and I am a staff software engineer at SurveyMonkey. Let me just start the slideshow here. And just 1 second here. Just want to take this out of this. Sorry, I don't like that presenter mode there. All right.
While we have this brief interlude, I'm going to sing. No, just kidding. I want to talk about our elevator. We have this elevator that brings people up, and it normally brings people down. However, at that witching hour of 6:30, they lock it. And so people show up, and they want to come up to the 6th floor, and they are denied access. Now, clearly we have to have... 6:05. My God, I thought that 6:30 was aggressive. Anyways, so at 6:05, the elevator locks. So that's why we have a Slack channel called Shopify Elevator. So if you're downstairs and you're locked out, one of the kind volunteers will come down and get you if you post something on Shopify Elevator in our Slack channel. Alternatively, you could send a kind message to our OWASP Twitter feed to say, you know, please let us come in. And for, you know, just the cost of your nice smile, we'll come down and get you. So I'm not sure what the logistical reasons are with the building. I'm really didn't want to spend, you know, I don't want to go down that path, but we're trying to figure out that if people show up a little bit, you know, fashionably late after the pizza, then there's a way that they can actually make it up. Have I killed this subject to death yet? Sorry? The horse is dead, yes, and talk nicely to the dead horse. Is that what you were saying? Okay. I have no words. Save me. Are you done yet?
Yes, I am. Yeah.
Oh my God. Sorry? Stairs. Are there stairs here? I haven't tried taking the stairs up here. I'm so weak. Probably the stairwell. Well, probably in this building at 6:05, all the stairs go flat and it becomes a slide. So, how many engineers does it take to set up a presentation? No. 3. I could tell you how many engineers does it take to screw in a light bulb? 3. 1 to hold the light bulb and 2 to drink till the room spins. My apartment was broken into. Yeah, they took everything and replaced it with an exact duplicate.
Okay. Sorry about that. When I was, yeah. You know, it's got this presenter view thing, and that's actually going to kind of screw up what I was going to do when I have the demo and I want to swap back and forth. So I took it out of presenter view, and we're going full screen now. All right. So once again, my name is Ben Whitney, and I want to help make your website more secure. I'm a defender. I believe in application security, and I want to protect websites from vulnerabilities. So a bit about my background. I've been developing software for close to 20 years now. I do APIs, I do security, I do architecture, I do all kinds of stuff. But security is a really fun topic, and I really enjoy it, and I like educating others about it too. So today we're going to be talking about file uploads and file uploads in websites. Now, a lot of websites actually accept file uploads. You've probably seen it quite frequently. You know, what are people uploading? Well, you could be uploading your resume. You could be uploading a profile picture. You could be sharing some documents with your team. But all these websites that are accepting these files, are they properly securing it? What do you think? So there are a lot of obvious things that people will try and prevent against. But it's all the edge cases that get you in the end. So let's take a look at what the actual process is of uploading a file, all right? So if you're on a client, you're on a web browser, you're a client, you click on a little dialog box, you pop it up, and you say, all right, here's a file I want to share. And you click submit, file goes over the internet, comes to the server, saves it to the file system, saves it to the database, right? Now you see in here, validation, client-side validation, server-side validation, okay? That's a very important step. The client side prevents the client from doing anything stupid, and the server makes sure that they don't. Now, a lot of times when people are developing web applications, they just do this checking at the client. They say, all right, whatever they're going to be doing through this web page, so if they can't do it through a web page, then they can't do it. Now, an attacker has a different perspective on that, and he's going to be looking at, well, there's an API attack surface here. So when you are adding file upload capabilities to your website, you're increasing your attack surface. You know, normally when you have data that's coming in from a client, you're taking in forms and fields, and you have to watch out for things like injection of XSS and you know, other types of vulnerabilities like that. But when you take in files, you have a whole new class of vulnerabilities that you're being exposed to. All right. Now I've listed a couple of the kind of issues that you'll see here. You'll notice that a lot of them are part of the OWASP top 10, and that's not a surprise, right? You've got broken access controls, sensitive data exposure, remote code execution. Okay, these are some very serious problems, right? So we have to make sure that when we add these kind of capabilities to a website, that we are aware of these risks and we try and mitigate them. So that's part of the goals for my talk. It's going to give you an awareness of some of these risks involved, and I'll give you some tips on how to prevent them. And I also want to ensure that you validate all your requests that take customer input. So here's a brief agenda of what we're going to be seeing today. First, I'm going to go through a couple of file access vulnerabilities. We're going to take a look at the problem of file enumeration and directory traversal. Then I'll cover several different examples of dangerous file uploads. It'll be large file uploads, zip bombs, malware, and remote code execution. And then I'll wrap it up with a conclusion and Q&A. So first, let's talk about file access vulnerabilities. So this is the risk that you have in a website when you're serving files that maybe somebody else uploaded. File enumeration is the problem of someone being able to guess the name of documents or other files on your system that they shouldn't be able to get access to, okay? Here's a real-world example. 2 years ago, in Nova Scotia, a teenager went and made a Freedom of Information request to the government. And he said, okay, I need information on this topic. So they send him an email that says, your request is ready. And they give him a link. And it's like, okay, Nova Scotia government website / request 12853, right? He's like, okay, clicks on that link, PDF downloads. He's like, oh, that's pretty cool. What happens if I change that number? He changes it to a different number. Gets somebody else's data. He's like, that's really cool. All right, what else is in here? So he writes a curl script, goes from 1 to 99999, downloads every document. Why not? Why not? Well, I guess the charged part is why not. So the government website administrators noticed that somebody all of a sudden went and downloaded every single file off their website, and they're like, well, that's not good. We just got hacked. Call the RCMP. RCMP come in. They're like, you got hacked. So they look up his IP address, go bust down his door, and charge him for illegal access of computer system. A couple people in the community sort of said, well, this is kind of stupid. Couple. And it said, well, maybe it's the government's fault for not securing their files in their website, and they're just embarrassed about it, so they are trying to, I don't know, make an incident out of this, right? In the end, you know, there was a bit of an uproar, and the charges were dropped, and they fixed their website. So, you know, that was the important thing, right? They fixed their website. But they learned the lesson of file enumeration. So what is the lesson here? Is that you don't give files a numeric sequence or an easily guessable name, right? There are random numbers you could use. You could use a GUID. You could give an access key, right? Generating a unique secret for each file. Or you could even make people log in and actually have a list of the files they're allowed to access, okay? But if you are hosting documents, like if you're accepting resumes, don't put them all in a numeric sequence where somebody can just, you know, use a curl script and download all your resources. Second one we're going to look at, and this will be our first demo, is on directory traversal, okay? So directory traversal is an attack where you are able to escape the directory that you're supposed to be in and go up to a different directory and get something else. So we often have the desire to be able to download a file rather than view it, right? And you send the file as an attachment, so it downloads to your web browser. And this takes a bit of a special processing if it's like a JPEG or something like that, because a JPEG would normally just render in the web browser, so you have to convince the web server to send it in a particular way. So you write a little script around it. Now, in this particular example, we've got getfile.aspx, and all my examples will be on ASPX files for now. But if you look here, we have an argument, file name equals terms and conditions. Now, that's cool. What if we change it to, you know, this doesn't exist? Well, probably get a 404 or something like that, right? So what I'm going to do is I'm going to show you my demo website here that I built just for this case, okay? And it's my file share website. Where is that? What's going on? Okay. Okay. So here's a little app. I made it. File share. Share your files with everyone securely. So we're going to select a file, okay? And this is how it would normally work, okay? So I'm going to upload a photo. Okay. Cool. Now, there's a file now, it's in my file system. Click photo. Okay. There's my photo. I don't know if anyone recognizes that. Are you a robot? Okay. Okay. So I've also got a download now so that somebody who sees this photo and laughs and they can like, okay, I want to save that to my computer, right? So they would click download now. Cool. All right. There. It's in my folder. But what did we actually do here? Let's take a look here. Let's take a look at the URL. I'm going to paste that in. All right. So there's the URL, and that's going to actually do the thing. Now, if I change that to /web I don't know if anyone knows what a web config file is. It contains your secrets. It contains all the settings that are controlling that website. I think Apache systems use HT access. So if you're familiar with that, it's that file. So now I just downloaded the web config file from the website just by changing the URL and putting .. / in the path. It's bad, but this isn't a demonstration of current best practices. Yep. Very good, yeah. So, here's an example, and oh, look, there's my database connection string with user ID and password, right? So, whoops, this was just from being able to download a file, just something that took an argument that was asking for a file. So that's a pretty big weakness. Boy, good thing it was just that. And, I couldn't go and go onto, the C drive and get anything that I wanted. Yeah. So, there's my system ini file from Windows, right? I mean, so I guess the point is that, yeah, you want to watch out for this particular vulnerability. So this was, of course, an example of some of the bad things that can happen. And as you folks, as awesome security people, know not to make these mistakes already. So let's take a look. So we first of all, we just sort of went through this directory traversal attack, and we start out in this path where our downloads were, and then we go up to www.root and inetpub, and then up to the C, and then we go back down to Windows and then System32. So that's where we got our file from. So it's fairly easy to prevent this, okay? If you're going to be serving files in this way, you need to block path characters like .. and / and \, probably pipe, colon maybe. All right, just block those from the parameter of the file that's being accepted. You need to be validating that the downloads are actually being served from your expected directory. So if you are about to serve a file, is it like, wait, is this still in the uploads directory? You can always do a quick little check from that and have a little sanity check. And lastly, you should be putting on access controls to prevent your web server user account from being able to access any directories that it shouldn't be accessing, okay? The problem is, by default, it might have far more reach than it should. All right?
Can I add something to that last point?
Sure.
Maybe set different user to different websites, so they're all securing, all website is secured independently instead of one user securing all the website, like that default thing.
Yeah, that's a really good suggestion. Yep.
Something to add. So what you're suggesting here is basically a context, right? So you have a list of bad, quote-unquote, characters that you should restrict in tasks. And it's known that blacklists are often ineffective because there are many creative ways of bypassing them. It's better to use whitelists. So you have a limited list of characters that you accept and you reject everything else.
Great. Yeah, actually, I'm going to be covering blacklists and whitelists actually in future parts of the talk, but okay. We'll do questions after this next section here. All right, so let's go on to dangerous files, okay? So here we want to protect ourselves from uploads. So what actually makes a file dangerous? Well, I would say if it causes denial of service, that would probably be dangerous. Or if it causes damage or harm to your web server, definitely dangerous. Or what about if it's a danger to other users on the site? You have to think about your clients too. They're why we're here. So first one I'm just going to touch on very briefly. It's not that big of a problem, but it's a good example of something that's innocuous but can be dangerous. And that's a large file. So let's say we have our job search website and they expect you to upload a resume, and you're normally uploading a file that's like 10 megs. But what if you upload a file that's 4 gigabytes? Well, if it accepts it, then it's going to be writing a bunch of data to its disk, and if they keep accepting stuff like that, or if you write a script to keep accepting that, then all of a sudden your website could potentially run out of space. Worst case scenario, you have your file sharing set up on the same drive as your web server, and then your web server stops working, or your database isn't able to write anymore. So, essentially there's a bit of a risk in accepting large files, and make sure that you keep a monitor on your disk space. So you should really be enforcing a maximum file size for uploads, okay? That's a pretty easy check to do, but you need to do that at the server, right? You can't just be checking that at the client and trusting the client for what it's sending you. You should probably restrict the number of uploads per account to make sure that things don't get out of hand. Even better, you store your files in cloud storage, like an AWS S3 bucket. And that way, you won't run out of space. You might go broke, but you won't run out of space. And as always, any kind of operation that's making changes to your system, you should be ensuring adequate logging of all the transactions that are going through there. So when something does go wrong, you can at least know who to blame. Cool. So now I'm going to show you a zip bomb. So some of you might have heard of this little file, 42.zip. Familiar? Okay. So this little file packs a big punch. So I'm just going to open that. Can you see that? Great. All right. So I've just opened up the zip file, and thankfully it's password protected, so that'll actually prevent this from blowing up my machine. But this little file has 16 zip files within it. And if you open a zip file, okay, the first one asks you for a password. Okay, we open that up. Oh, there's more 16, more zip files, more zip files, more zip files, more zip files. And then at the end of each zip file is a 4.5 gigabyte file. Now, the great thing about, like sparse files is they compress really easily. So it's probably, I think it's just like all A's. It's like, right? But that still takes up a lot of space on your hard disk. How much space does it take? It takes up 4,500 terabytes of space if you try to unzip that file. Now that's pretty cool, right? And it's 41.8 kilobytes. Amazing. Now, where this becomes weaponized, a weaponized zip file, is when you send it to something that processes a zip file. So let's say you have a website, and your website allows you to zip up a few documents, send them over, and then it'll unpack them and do something with it, right? Now, all of a sudden, your system is trying to unzip 4.5 petabytes of data. So that's going to be you're going to have something crash there. You're either going to run out of RAM, you're going to run out of computer, or you're going to run out of time. But it's going to be basically a denial of service for your website. They used to these have been used for example in the arms race against antivirus. So virus versus antivirus, where people would put a virus inside of a zip file to try and get it past the antivirus. And then, of course, the antivirus is like, well, we're just going to scan zip files. So then they said, well, we're just going to keep you busy for a while and send off a zip bomb. Okay, so how do you prevent zip bombs? Well, they're not great, but if you run antivirus software, they can potentially detect zip bombs. If you have code that opens zip files, make sure you have enough space to extract that zip file before you begin. You don't want to go through this process because it'll take your machine forever if you don't actually do it. So you should be testing your own server against a zip bomb attack if this kind of situation is possible for you. And you'll have to remember that there's other file types too, like MS Office documents, like DocX, PowerPointX, XLSX. Those are zip files. And when they try and load those zip files, they could be potentially unpacked by anything that's processing an Office document. So something to be cautious of. All right, next we're going to talk about malware. So what's stopping someone from uploading a virus to your website? Not a whole lot, right? They could try and upload it. And if you got antivirus, it'll probably stop it, right? You have antivirus, right? It actually stops it? Are you sure? So that's a problem, right? Somebody uploading a virus to your website is not going to infect your website, right? It's not going to be executed on the server because the server isn't going to go and execute that exe, right? It's more for other people to catch, you know, and it's going to be, you're going to be putting it up there for the hope that somebody else downloads it and infects their system with whatever malware is put on there. So, you know, it's not a very sophisticated attack, but it is something to be careful for. Now, if you're somebody who's defending websites and building websites and you want to be able to test for a virus, but you don't want to actually destroy your computer, what do you do? So there is a file called icar.txt, and I think Sharif was actually talking about it in the last presentation. This is what it looks like. It's a little text file that has a little string like that, and that's a virus signature. And the text file itself is harmless, but the virus itself, virus scanners themselves are meant to detect this. So if you want to test your website against antivirus, then you take this text file and then you upload it to the website. So if I went to my cool vulnerable app and selected a file, selected that. Okay, oh, cool, you know, all right. Then that would mean to me that there's not antivirus running on this system, okay? So that's something to know. Go away, Bitdefender, all right. All right, so yeah, we'll go back to the presentation and, okay. So, yeah, if we're uploading files, you want to block exes, coms, and all that kind of stuff, but what about all the other types of file extensions that you can be blocking, right? And once again, the most important thing is to not use a blacklist, it's to use a whitelist of allowed file types. Okay, so if you're accepting docs and PDFs and JPEGs, then that's the only types that you accept, and you prevent all others. You don't say, is this an exe? Throw it away, right? You need to always run anti-malware on your server, okay? If you're going to be accepting files and you're going to be sharing them with the public, you should really be doing this. It's a public service for everybody. And as I showed, you can test your site using the icar test file. Okay. All right, last part of the demo. This one is remote code execution, and this is actually one of the most dangerous vulnerabilities I've ever seen. It allows an attacker to execute arbitrary code on your website. And it's in a surprisingly obvious, but, you know, not well-known way. So let's do a demo. So this website, it doesn't block any file types. I could load an exe on here, but it's not going to run it. It doesn't matter, right? But it's an ASP website. So I've got this little file, and it's called helloworld.aspx. All right? So this is going to actually just write out, response write, hello world, and terminate. So if I upload hello world, okay, and I go there, there you go. All right, hello world. I just executed code on that server. That's pretty cool. Now that's a basic example. That's the literal hello world of what you can do. Now, I'm a bit of a developer, so I wanted to write a little bit more of an example script. So I just wrote a few functions to do some cool stuff on the website. And I'll show you what you can do once you actually have a site that accepts this. So first of all, do we understand what's happening here? We have a website that is ASP.NET, so it accepts it serves ASPX pages. And I am uploading an ASPX page to it. It was expecting documents, but because it's being served in the website, I am now writing up code that it's going to execute for me. So if I can write ASP files and upload it, then I can have it do anything I want. So I'm going to upload pwned.aspx. Boom. Okay. Now it's going to be running my process on the server. All right, cool. So let's take a look what we can do. Well, I got some environment variables. I found out the operating system version. I found out what directory it's running in. Oh, here's how much space is left on the C drive. Oh, cool. Here's a list of the folders in the C drive. I could actually turn this into a browser and allow you to just search around and download any files on the file system if I wanted. Okay. I've got tools. So we can write a file. We can drop a payload on the website. So let's say we wanted to deface the web page or replace any content or drop a calling card like OWASP.txt. So I just did that. Okay, so we'll show that. So I just wrote this file. Maybe I didn't. Oh well. Anyways, that one's supposed to work. Okay. And finally, I can pop calc. So just launch the calculator app. So if you can do this kind of stuff, you can do anything with the server. The possibilities for an attacker are limitless. They can put in a remote shell. They can encrypt all your files and ask for Bitcoin, right? That's all made possible just because the developer of this website allowed an ASPX file to be uploaded. As even if it has limited lockdown capabilities, it can be used as a bridgehead to expand and further into the network and into the file system. So definitely some risks associated with that one. This is just an example with ASPX files, but what if your site's PHP? Are you blocking PHP files from being uploaded? Or any other files of that type, right? So how do we prevent this? Well, you need to enforce all validation of the server, okay? If you have a client that's blocking, doing that block list of files or saying that, oh, I only accept doc and JPEG here, and that's just in your client-side JavaScript code, but then you have a server endpoint that accepts anything that you give it, then they're going to be able to get past that, and they're going to be able to get files onto your system that maybe you didn't expect they could, okay? Of course, we want to be using a whitelist of allowed file types rather than a blacklist. And very importantly, you should be disabling execution of scripts in file shares. So if you have a directory on your website that's being used to share files, make sure that scripts can't be executed there. So that was, I hope, a pretty cool vulnerability. I'm going to wrap it up. So here's what we talked about today. We talked about 6 different vulnerabilities, from file enumeration and directory traversal, where we're getting at files that we shouldn't be able to get, to causing denial of service, malware, remote code execution, and I hope you learned that you should always be validating your data at the server. So, thank you very much. Are there any questions? Yes.
Can you show your validation slide, validation?
Which one?
The one you showed validation. Yeah, this one.
Yes.
So if there's a bug in the validation process, and you bypass that, and you can do whatever you want.
You have to make sure that your code doesn't have bugs in it. Right. Well, that's it. Everything we do is an exercise in writing code of good quality. And validation routines are ones that must be checked as well. Yes?
Well, one good thing to do for that, for anything upload-wise, is to put all your uploaded file outside your application room, so they cannot be executed and called over HTTP. So that way you're way safer.
And my comment in general, we do the validation, whitelisting, etc. But if it's the vulnerability on that server, you can use that and bypass all the validation, all the whitelisting.
Yes, but if your file is outside your web room, you cannot execute it.
Yeah, that's what he said. He said make sure you put it in a folder that doesn't allow for execution.
Yeah. And of course, you can't be having any components with known vulnerabilities too. Oh yeah, yeah, exactly. These are just 6 examples of the type of problems, and you know, I wanted to keep this to a half hour because you know it's get thirsty up here, right? But this is just the tip of the iceberg. What the purpose is to get you to think and to use your skills as security people to understand the problems and keep digging in and like, well, what are all the ways that we can be screwed over? So that's what we're trying to prevent here. Any other questions? Nancy? I'm not sure if there is. Yeah. Yeah.
With your phones.
I'm sorry, no what? Cheat sheet for which?
File uploads.
I think it's covered in like the generic cheat sheet document. Like there's the big cheat sheet document that's supposed to be someone's GitHub, I'm sure. But it's got like separate sections for everything, and I'm pretty sure it's got a section for file upload for which
Very cool.
I have another thing to add. Annoying a bit, sorry. But you did say many times validate on the server.
Yeah.
I go even for if there's beginner here, never trust a client. Basically, that's rule number 1 in web development. Never trust
Yeah.
a client. Not just validate on the server. Don't trust your client.
Yeah.
That's super easy to exploit. I mean,
Yeah.
you open the debugger in your browser, you do whatever you want, and you just query HTTP. Super easy.
That's exactly right. The web browser is completely an unsafe environment. You never send a secret there. You never put anything there that you wouldn't want exposed, like source code that would be giving you secrets. Okay, and any data that's coming to your server, you have to consider the API is the gatekeeper, right? So whatever you're accepting data, that is the ultimate decider. Okay, thanks very much.
Thank you. Thank you very much. So as you know, we do this monthly, so we've already got presentations scheduled for March and April. If you have an idea you want to share, lightning talk, small talk, the full Platinum Deluxe Edition, you can talk to me, you can talk to one of the other volunteers, you can talk to one of the other leaders, or you can just post it on our Sessionize site, of which the address for I have not memorized, but if you look at our Twitter handle, it's in there, or if you want to ping us on Slack, it's on there as well. If there's nothing else, then we'll see you next month.